So another question that we have is, while standing on the box, how much room will they have from like their head to the ceiling, or from their arms to the wall, or just around the box to know if they'd be able to lie down or stuff like that?
Right. Okay, so it's a very, very tight fit in there because we're talking about the Orion vehicle. And so we're actually butted up against some seats, and the bathroom, or whatever you want to call it, waste compartment place, is actually going to be underneath you. And so we do have some logistics constraints there, because we're going to have to make sure that people are going to be able to get around and under and all that stuff too. So I can get you some of those specifications on how much volume you actually have around that box, but it's going to be very limited, and we don't actually have enough room to do overhead type exercises. And so it's going to be probably the highest that we're going to be able to get is going to be more like the squat.
I will mention, though, because that's a really intuitive question. In general, NASA really tries to design for the 5th to the 95th percentile human being. So that's essentially the smallest woman to the tallest man. And I think that ends up, Renata, what is that, like a 4'2" in height person up to a 6'3"?
Yes, probably closer to like 4'10", 4'11", and that, and then up to a 5.
Okay.
Yeah, a 6. That's right. Yeah. So we need to.
Those are.
Get through the whole range, yeah.
Yeah, and so we really try to be inclusive of that range of what we call the anthropometrics. Sometimes it gets tight and we can't make it. And so as you can imagine, that in turn limits the size of the crew that can be selected for these missions. But I thought it was important just to share what we try to do and where we actually realize some limitations when the design of the vehicle has the waste containment compartment too close to the seats, and the vehicle designers haven't worked closely enough with the human systems teams to understand how we're all going to be asking the crew to work and move around in the vehicle. So that's a really great question up front. And I like the systems thinking you already have.
So do you guys know how much we're able to move the wire and what the resistance is that it has, and if that is adjustable?
Right, so the device that we're currently building is supposed to be able to get up to 400 pounds of force. So we're going to go from 0 to 400. And as far as the cable length, we do have some specifications on that, but basically a 6'3" person should be able to at least be able to get it up above, close to their top of their heads.
So a better question that I have is, if the wire were to be, I don't know if you guys are able to see this box that we have constructed. So the wire as is will go up and down like so. Will we be able to move it to go sideways, or just rotating it simply?
Yes, you should be able to move it to wherever you need to. You just have to remember that your foot placement is going to be on the box itself. It's going to be really hard to actually come off of that box and do anything, so you're going to be restricted by that. I like your box.
Thank you.
Do you have a retractable cable on that right now?
We just have a rope that we improvised with a string that you pull through.
Okay.
Yeah.
So as far as the dimensions of that box that you're using, what are you using?
What are the dimensions of this box?
It's about 16 by 16 by 5.
Okay. Yeah, that's small. Okay.
And I note that you have the wire coming right out of the center of the box. Renita, I believe in one of the current designs, isn't that a little offset more towards the front of the unit?
It is. It's a little offset more to the front. And so we can probably give you an approximate location for where that cable is going to come out, because I think we don't actually have the final design, and so we don't know exactly where that's going to be. But there's one that comes out the center, closer to the center, and then one comes out closer to the front right now, and so we'll have to play with that a little bit.
I'll also mention. Oh, go ahead. Sorry, Anita.
Yeah, so for purposes of this design, we can just fix that and say, here's where the outlet's going to be, and then this way they can come up with whatever angles it's going to come out to hit the actual harness itself.
Quick question. So with the foot placement, is there going to be like foot holes that like strap your ankles in?
Yes, there will be something to help you keep your feet in there.
Okay.
And I'm not really sure if you guys know, but our device is actually being used for both resistance and aerobic exercise. So we're going to be using it for rowing as well. And so we're going to have places to attach the foot plate so that you can row on it. But there will also be, normally when we're doing resistive exercise, we don't necessarily have to strap in because you've got the weight of the bar that's helping hold you down. And so, but we will also have some foot straps on there to keep your feet in place.
And just to circle back on a question you had asked about being able to pull the cable to the side, with the current device, it is more of a kind of a wide strap, I would say. You can kind of imagine like a webbing or a wide strap. So it's not a rope-like cable coming out of this particular box. So in order to keep it on its recoil pulley, there will be limitations in side-to-side pull. Did you have anything else to add to that, Renita?
Yeah, that's true. So the Med 2 right now has the webbing, but the Dart and the Rocky, they both have like more of a cable. And so we probably can. Yeah, the flywheel is more of a webbing. Yes, correct. So we have a combination, and so that may be something we also need to set for them and just say, here's what your cable is going to be coming out, so that they can have a better idea of like what kind of, I don't know, like load path and trajectories you're going to have off of that cable coming out to the harness. And so we'll have to give you some of those specifications. And again, this is just going to be, for this project, here's what we're going to assume.
And what kind of, can you explain to them all the different kinds of exercises that you're expecting that you'd be wanting to see them do using this exercise device? Yeah, using the harness.
Right, okay. So, let's see, we're going to say that a couple of the main exercises, the main exercise that you're going to want to do is the squat. And so are you guys familiar with the squat exercise?
Yeah.
Yes. Okay. All right. So the problem is that with a single cable device, there's no way to actually have a bar on there to load onto your back, right? So that's traditionally how we would want to do a squat. And so the harness is going to give us the ability to do a squat, to distribute the load, so that you can get the best physiological effect out of it. And so probably, Andrea, maybe you could give me some input on this. Maybe we should just limit their harness design to the squat. What do you think?
I think we could limit it to the squat, or when we think about what the full capabilities of the system should be, we want full functional body movement. So if you can imagine with a single cable, it makes it difficult to perform those traditional exercises like the squat with just that one cable in a small bar, and that's why you're focused on building these harnesses. But another desirement of the exercise system that we really currently don't even have today is to provide some of those real good core exercises. If you can imagine like a lawnmower where you're squatting down, you're bending, you're reaching across your body, you're coming back up, and you're twisting your back. So those are some of the exercises that we would also be interested in seeing the crew be able to perform. But I would prioritize, absolutely, Renita, I think the squat exercise would be a great place to start, and anything else would kind of be bonus from there.
Right. So when we're talking about the squat and the harness, we're talking about having a single point attachment. And so the harnesses that we've seen in the past have had the harness attachment point right about like kind of between your legs. And so I think what Andrea is talking about was not only are we going to want to do a squat, no, we're not going to be holding anything, but a squat, but we're also going to want to maybe do some type of twisting exercises so that you can be able to work in your core. And so you want to make sure that since you guys are a physiology class, that we're saying that this harness is going to give you the most effective exercises because you have a good loading path for the squat, plus you also have a way to distribute your loads, and you also are able to do some level of twisting and core exercises. So I think we could probably maybe encompass all those things. What do you think, Angela?
Yeah.
Does that sound?
I think that'd be a great idea, because one of the real issues that the astronauts deal with in space adaptation is they experience back pain because the spine elongates as soon as they get to microgravity. And so the more we can stabilize those small spinal muscles, the better chance we have of helping them to alleviate that pain and maintain a strong back so that they feel comfortable when they return to Earth. So that's kind of what drives the need for those types of exercises.
So maybe what you guys can concentrate on is like the correct form of a squat and the particular, I guess, pitch points and pressure points that you might have with a harness, and then how it could affect your lower back as well as at the high loads, especially because if you've got 400 pounds on you, then that can affect how that load feels on your body. And so that could be something that you concentrate on. And part of the reason that we're trying to focus you guys because there's a lot of different things that are affected by this harness, and we also need to make sure, like when we get ready to fly something, that you have the right materials and that you have a lot of the right. You may decide you want to instrument it. That could be something that's considered, especially, I don't know how many of you guys are in the engineering class, but there may be some instrumentation that you add to this harness that allows you to actually be able to measure the pressure points or the load at different parts of the harness. And so that's, we want you to kind of think outside the box on what is the best kind of information you could provide back.
Okay, question for you as well. This is Miss Stefano. Hi, how are you?
Hello.
We, thinking of the squat, so it's clipped on right in between the groin area, but are you going to be able to have another clip on? So if you're doing a squat with the deadlift, or is there an extra device that you can clip on? Are there two different clip areas, or is it just one there and then it's movable?
Yeah, I think that's an excellent question because some of that stuff is not actually defined yet. And so we even talked about, maybe, so you can come back to us and tell us how many attachment points you might need to have the best form. And so we even talked about maybe even having the sliding, type of attachment. So this way you can have that load distributed properly. For the deadlift, we probably will use a bar on the actual cable, and so that may not be the right exercise that we're thinking about. But for other things, you might figure out a way to have that attachment points at different places, or be a sliding mechanism, or something that that helps you actually distribute that load properly.
Okay.
Andrea, do you want?
Oh, sorry. So when you're would you unclip from the groin area and then clip it somewhere else, or do you have multiple clips areas, like multiple?
So we
coming at like the multiple coming out of the box is what I'm trying to.
Yes, we only have one right now.
Okay.
It's in the middle.
So we do have a design right now which is trying to split the load, and so it actually takes a single cable and takes it into two attach points so that you're able to take that and attach it to two different spots. And so that is currently in work as well. So again, if you guys want to come up with, here's what our recommendation is for the best way to get the most out of a single cable device, and say, okay, we really need to split that load, then you guys can come up with a recommendation on how you want to split that load, and you'd actually have to come up with whatever that accessory is to say, okay, here's how we would split that load.
Okay.
So another question that we do have is, are you able to add things to the box so that if we're able to essentially have, if we're essentially able to have like a string wrapped around the outside of the box or something like that so we could clip things onto it? Is that a possibility?
Yeah, I would say that is a possibility. You do have to be careful with structures as far as that goes, because you have to remember how much load you're actually putting into this device and onto this device. And right now our limitations of like a 20-pound box is very small, and so you need to make sure that you take that into consideration. So you could attach to it, but you have to remember that you've got, you could have potentially, 400 pounds of force being pulled up on this attach point. So you would have to do the analysis to say that your box can withstand that. And I guess I'm not exactly sure what specifically you're talking about, but if you would want to draw it out and show what your load path is and how you would be able to analyze it to say that you can withstand those loads, then I think that would be good.
I know there were some questions that had come about from your class talking about, being able to do something off the box, like laying down next to the box. And I believe that, the answer to that is that no, we're staying on the box. So there's not going to be any, and really in a microgravity environment, if you're talking about trying to do push-ups and sit-ups and stuff like that, you can't really do that in a microgravity environment. There has to be a different way that you're accessing those muscle groups that are not using that. Am I correct in saying that?
Yeah, I think we're more limited by volume in this whole environment, and so you could maybe think of a way to sit down on the device and be able to do core exercises if you're attached to it properly or something like that. And so we could probably explore that further. Okay, but I don't think you could lay down next to it. There's just not enough room.
Go ahead.
Hey, do you know if it's possible if, like, how our feet are gonna be strapped in? Is it possible if you can lift one leg at a time while the other one is strapped in?
Yes.
Yes. And how close is the box to the wall?
It is actually right up against the wall because we're using it as a step to be able to egress the vehicle. So I can send you a picture kind of what the proposed location and orientation is of the device so that you can get an idea of how we're exercising in the vehicle. I think probably, Andrea, we have non-proprietary stuff we could send.
Yeah, I think so.
Awesome. Also, can you add attachments instead of attaching this to the harness? Can we add attachments for?
Yes.
Yeah.
Absolutely. Yes.
You guys have any already?
We do. Right now, the way it's written is that we would like to have accessories added to be able to do different types of exercises.
Okay. Also, is it possible if we can get the astronauts' body dimensions, such as their arm span, their hips, their waist, their chest, and then shoulder to shoulder? And waist.
That's a very good question. So right now, as Andrea mentioned, what we try to design for is for the 5th percentile, Japanese female to the 95th percentile American male. And those dimensions are actually published in a NASA document. And so we would normally try to design for that entire range, which is very small female to a large male. And so those are actually published numbers with published spans and different dimensions. And so I'm sure we could probably give that to you, but for purposes of this project, Andrea and I can talk a little bit more. We may have to narrow that down for you depending on how much adjustability you think you can provide.
Well, and the purpose of us asking is another idea that we had for our harness-based part of the project was to essentially make custom harnesses for each astronaut as one of our ideas. So that is the purpose of us asking sizes, just so we can have a better idea of what sizes we're trying to construct them to be within.
Right. So I think the reason that we stay away from custom harnesses for each astronaut is the volume that it takes up. is that we just don't have enough room in the vehicle. So what we would prefer is something adjustable.
Okay.
And
Yeah,
if you came back with that, we would have to say that it's probably not realistic, because we just don't have enough room for that much volume of equipment.
I'll even share the condoms that we use today. We use adjustable harnesses in the sense that they come in two different pieces. So there are upper pieces and then lower pieces. So you have kind of a small, I think it goes actually extra small, small, medium, large belt, and same for the top straps. There's a modified variety of that and an unmodified variety for the top straps that were basically meant to are designed for males versus females, but the crew are finding they all prefer kind of the modified version of that. And that's the harness that we use on treadmill today. So even for the astronauts today, they don't have a real customized fit. They do have to find the best fit within those matching the best upper and lower sizes for their purposes. And of course that changes because your body size changes and volume changes when you get to orbit. So they might have a really good fit on the ground and find when they get to orbit, they might have to swap out with their crewmates or try to find a harness that wasn't previously used or left behind to try to get a best fit. So that is what we call the concept of operations today, is to use those adjustable harnesses.
And I think we also have quite a bit of research that's been done on backpack designs to be able to distribute your loads, because there's been a lot of studies. So you guys might want to do some research on that. You probably look online and see what's been done in the past for being able to carry heavy loads.
We have about probably 8 minutes before this conference ends. If y'all have additional questions, we can definitely send those to Andrea and to Renita as well. So just probably a few more questions.
So we do have one more question, and this one might be a little bit of a stretch. Is there any chance that we'd be able to get a picture of like a 360 degrees view of the area that this box would be in?
Okay, I didn't hear that.
I think she's looking for kind of like a cat, like a modeling of the inside of Orion, like where the box would be placed on the inside of Orion.
Right. So yeah, I think we do have some things. I just need to make sure that proprietary stuff isn't sent out. But we do have some just kind of general, like more like cartoon-like drawings that we could show you guys.
Yeah, we have some material that's been through export control to share.
Yeah.
And you might have answered this question earlier, we might have missed it, but did you tell us if we're able to change the resistance range of the wire, or it's set at that specific 400-pound force?
Yeah, that is the force delivered by the device is absolutely adjustable. So I think it can go, is it as low as maybe 50 pounds and as high as 40, and so you can adjust it at depending on the device, but at minimum, I would say 5-pound increments. Renita, we'd have to decide which exact device we're going to be, referring them to decide what increment of load that we adjust that at. But yeah, you can say just for now, I'd say you know that you can go from 50 to 400 at incremental loads. Yes,
correct. I mean, in most of the motorized devices, you can actually go all the way down to 0. And so, you could have no load on there and then go all the way up to 400 pounds. And you can actually do it in 1-pound increments if you really wanted to get down to that level. But most people don't exercise by 1-pound increments.
So an exercise that you had brought up earlier was the lawnmower exercise, which involves a pulling and twisting motion. If you were on the box and it is centered in the middle, would you be able to step off and stand essentially like with your toes pressed against the box, your feet locked down, but not on the box itself, so you would be able to do that exercise as opposed to having it be like straight up and down and not doing that exercise to its full potential?
So I think right now it's pretty tight as far as things being right up against it. So we don't have the final layout of how it's going to be in there. I think realistically, probably astronauts will figure out ways to be able to step off the device and do something with it. So that device is going to be hard mounted into the vehicle. And so if they could find a spot to stand, I'm sure they will. But I don't think we can rely on that as an option.
I think that's it.
Everybody else?
Okay, awesome. So I'll work, Allie, I'll work with you on trying to figure out what their milestone dates are. Okay, so that I can kind of get a better understanding of what you need to have by when.
Right.
And then we can go from there. And then whatever they want to provide to us, Andrea and I are happy to look at any products that they might want to send our way, whether it's design drawings or things like that. So we can help.
That sounds great. And we do a lot of everything right now. We're doing through Google Drive.
Okay, perfect.
So we can share it. We can share it that way.
Andrea and I both have Google Drive access, and so we can do that.
Okay.
I guess can you kind of just give me an idea of like what kind of maybe budget and
yes,
and,
we can
and
talk
resources are?
We can talk about that offline.
Yep.
We can talk about that. Did you have another question?
Really quickly, are we able to ask, is that a version of a harness that is on the table right in front of you?
Don't worry about that version. That was like another school's version. I pretend like it's okay.
But I think, Renita, we could probably share, we have a really interesting history of harness design, and they've all been designed for the treadmill. I think we can certainly share that with you to kind of see what design iterations others have gone through and some of the features that they found beneficial for the running exercises. And there's a lot of crossover to interfacing with the single cable device too.
That'd be great.
Yeah, I think that would be good. We'll have to see what we can send to you and package it so that you can take a look at what's been done in the past.
Awesome.
Thank you.
Great. And hopefully we can have some, future web conferences if there's more question answer, if you guys are okay with that, in the future.
We're happy to
Allie and others. So November 30th, the design review that's at the Wings Over the Rockies, you would like to see our team with a working harness at this point?
Dan, we'll talk more about that, and because I need to kind of figure out where you guys are with things.
Okay.
Critical design review, definitely.
Okay.
So preliminary design review, we'll talk. I'll send you an email, or we can talk on the phone.
Okay.
So, okay. All right. Great. Well, thank you all so much for your time. Appreciate everybody's help today. All right, y'all take care. Enjoy your snow.
Oh,
yeah.
All right.
Yeah. All right.
All right. Take care. Thank you so much, Andrea.
Thank you.
Yeah, thanks for having me join you today, and just good luck to your design. I love that you guys are thinking about this and can't wait to see what you come up with.
Thank you so much. We appreciate it.
very cool.
Thank you.